This is the solution to Chapter 5's problems: stationary soccer ball force, movement soccer ball force, and soccer ball during a kick. While you and your friends are playing soccer, one of your friends asks you what the forces on the ball are, prior and after the kick. First, since the ball is not moving, you only have two forces acting on the ball: the weight, which is mass times gravity. Mass is the amount of matter an object is made of, and gravity is the force towards the center of the earth. The weight vector will be pointing down. Next, we have normal force, which is the force opposite from what the object is on. Basically the force created by the ground so it will not fall through. The normal force vector will be up. The vectors are equal in magnitude due to no movement. They will cancel each other out because of Newton's second law, F net equals mass times acceleration, where acceleration equals 0, thus all the forces must cancel out. Now your friend asks, what are the forces during the kick onto the ball? Since the ball is being kicked to the right, we draw a force vector from the ball to the right. The important thing to remember in a force diagram is that this is happening as a snapshot, so this is applied right as the ball is kicked. Normal force and gravity will be the same. Now that we've finished our force diagram solutions, we are going to move on to the soccer ball during a kick problem. Here, we are trying to find the force of the kick onto the ball if the ball's mass is 430 grams and the acceleration is 27.8 meters per second squared. We will use force equals mass times acceleration. First, we need to convert all the variables into International System of Units, or SI units for short. For mass, it is kilograms. For acceleration, it is meters and seconds. If those are correct, force will come out correctly with newtons. In our case, everything is correct except the grams, which we will convert by dividing 430 grams by 1,000. This will give us 0.43 kilograms. We will then multiply the mass by acceleration of 27.8 meters per second squared, and this will give us a force of 11.954 newtons. With sig figs, this will be 12.0 newtons. Now that we are done, I would like to point out the main takeaways from the problem. Set force diagrams are a snapshot of what is happening. Think about the motion and what is acting on it. Weight is the force of gravity, and normal force is the force against the surface. The forces vectors will cancel out due to F net equals mass times acceleration, and in our case, acceleration was 0. With the final problems, take a look at the pyramid on the right. You can use this for the relationship of Newton's second law, force equals mass times acceleration, where you can take the top force portion, which is force, and divide it by one of the bottom variables, acceleration or mass, to find the other missing variable, acceleration or mass. You can multiply the bottom two variables to find what your force is in your problem. Thank you for listening.